SwayamPrabha. Digital India. Educated India.
Friends, in the first lecture on Introduction to Production and Operations Management, we studied the purpose of Production and Operations Management, and the purpose is customer satisfaction by providing good quality products at a competitive price and delivery at a place and time required by the customer. And the fourth dimension was doing the improvements, innovating the product. Then we also studied that a system consists of inputs, transformation process and output, and there is a feedback loop also in the form of measuring the productivity, measuring the efficiency, measuring the effectiveness and measuring the competitiveness of the system. Now, in this second lecture, we will talk about, we will study the different types of production systems. This classification, this understanding is very important, because certain decisions are highly desirable in a certain production system, but has no application in some other production system. At the same time, the issues involved and the applications involved are also different. The third important aspect of this study is, so depending upon the given requirement, we should be able to identify, we should be able to design the right type of production system. So, keeping this threefold requirement: one, that I should be able to understand what type of production system is required for a given set of requirement. Number two, what type of techniques I should apply to improve the efficiency, to improve the productivity, to improve the competitiveness of that system. And third is to see that the system is relevant. So, in that context, we will study the various types of production systems, and to name them, we are going to study in first, there are several such kind of classifications are there, several types of terminologies are there. So, we will study first set, which is very popular terminology and classification. By this classification, we can divide our production systems into 5 categories. First is called continuous production system, second is called mass production system, third is called batch production system, fourth is called job shop production system, and fifth is called fixed location production system. Let us understand what is meant by continuous production system. In continuous production system, as the name suggests, the output of the system is continuous in nature. Just like your refinery, petroleum industry, you are feeding the crude oil from one side, and on the other side you are getting the continuous flow of refined oil. Similarly, sugar industry, cane sugar, you are feeding the cane from one side and other side you are getting the sugar. Similarly, the manufacturing of biscuits, duff is there, which is getting passing through several stages, and ultimately the cooked cookies are available. Similarly, the textile industry, spinning mills, the output is continuous in nature. Weaving also, the production of cloth is continuous in nature. So, these type of systems are called continuous production system. The typical feature of these kind of system is it has very less variety of inputs, like in case of textile, if you are producing a cotton yarn. So, only one type of cotton is there which is fed, and ultimately you are getting various types of yarn you can produce of different counts, different texture, different mix also you can produce. Similarly, in case of textile also, you are feeding the yarn and then you are getting the fabric. So, input variety is very less in a continuous production system, and material moves from one internally only move from one stage to another. Then come these 3 types of production system: mass production system, batch production system and job shop production system. These production system, this is continuous, these are discrete production system. Like manufacturing of cars are coming at interval. First car is produced, after 50 seconds, after 1 minute, after 2 minutes, another car is produced. So, that is called discrete production system, where the flow of output is not continuous, rather it is discrete in nature. Okay. So, that is and now comes the see the difference between mass production system, batch production system and job shop production system. The difference between these three systems is based on volume and variety. In case of mass production system, volumes are very high and variety is very small. So, that is the cell for mass production system, where you are producing one type of a car, one type of a product in large quantities. Then there is a batch production system, where there is a moderate variety and moderate volumes. Most of the examples here are ancillaries are there, or a companies which are producing several models from the same set of machines. So, you are producing variety and volume. And then there are customized products, job shop production system, tailor made item, job shop system, where the variety is very large. You are going to a tailor to get stitched just one shirt, or you are going to a service center, car service center, where each job card is created for your job. So, that is called job shop system, where the variety is very large and volume is maybe typically only one unit is getting manufactured. So, based on the volume and variety, we can classify mass production system, which are high volumes and low variety, batch production system, which are moderate volume and moderate variety, and then job shop production system, which are having very high variety and very small volumes. In factory, you will find tool room is one example. As I said, tailor made item is another example. Car service center are some examples of job shop production system. In case of batch production system, the examples include ancillaries, which are producing several types of gears for the OEM, original equipment manufacturer, car manufacturer, Maruti or something, and then large number of gears are required, which is manufactured by the ancillary. So, they keep on changing the batches. First they produce a batch of one type of gear, then change and produce another type of gear, then produce another type of gear. So, that is moderate variety and moderate volume. And in mass production system, you are producing only one type of a product on a given equipment. Earlier, most of the companies used to be mass production system. If I see at a scenario of 1980s, very less variety and items are produced in large quantities, because at that time we used to call it seller's market. You want to produce as much amount as possible. You might have also observed that in case of mass production system, the productivity is very high, because you are not making any changes. Years together, months together, you are producing the same type of product. So, the productivity of this system is very high. Productivity of mass production system is very high, whereas the productivity of job shop system is very low. The productivity is very low. On the second side, we say that the flexibility of this system is very high. It can produce any type of product. The flexibility is very high, whereas here the flexibility is low. The mass production system has low flexibility. So, on one extreme we are having mass production system, which is highly productive, but less flexible. On the other extreme we are having a job shop system, which is highly productive, but very less which is less productive, but high flexibility. We will study in the next slide the JIT production system. The foundation of the JIT production system is to develop something which is highly productive as well as highly flexible. So, JIT system we have developed, which is highly flexible, productive as well as highly flexible also. So, that is the feature of JIT production, we will see that. Then the fifth type of production system is fixed location production system. The fixed location production system. The fifth type of production system is fixed location production system. This is also called project shop. This is like construction of a flyover, or manufacturing of ship, aircraft, etc. because of the sheer size of the unit which you are manufacturing, it is not possible that unit moves from one workstation to another. In these 4 workstations, we found that material or the job moves from one station to another, whereas the production processes are stationary. Whereas in the 5th type of production system, the job is stationary, but the processes are portable. The processes are portable. In fixed location system, flyover is constructed at one place. So, job is not moving, or aircraft is getting assembled at one place, aircraft is not moving, whereas other components and parts are coming and adding value to the product with the help of mostly portable equipments. So, that is the difference between the first 4 and this particular. First 4 are where the jobs are moving, whereas processes are stationary, whereas in 5th case job is stationary, whereas the processes are portable, they move and add value to the product. Now, let us see in detail the various types of these production system, the salient feature. Most of the studies, the challenge is in management of these 3 systems. There are very less management issues in continuous production system, because once you set up the plant, the management of this system is very easy, because of not many changes are taking place, though there are certain aspects which we will study there also. And in fixed location production system also, this is more studied as a project management topic. So, most of the studies are related to most of the manufacturing, 80-90% manufacturing system is consisting of mass production system, batch production and job shop production. So, that is why this is the, and JIT etc. and the present day all supply chain management issues are more relevant for these 3 types of production systems. As I said, variety and volume, mass production system less variety and high volumes, batch production system moderate variety and modern volumes, and job shop production system very high variety and very less volumes. We can understand the classification with the help of this particular diagram also. As I said, project process, it is one of a kind, project process is one of a kind, like construction of a ship, flyover, unique kind of a thing made according to the customer order. Whereas job shop system low volume and low standardization, high variety. Third is the batch production system, multiple products and moderate volume. Then line processes, mass production system, few major products and high volume, and then continuous production system, high volumes and standardized commodity. As I said, manufacturing of yarn, fabric and refinery and sugar mills etc., they are examples of this. If we look at this side, what are the processes characteristics? This is the product characteristics. Let us see what type of processes are required for this. In case of projects, it is a complex and highly customized process, and coordination of the activity, sequence of the activity and coordination of the activity is the desirable thing. The management aspect is how to coordinate the various activities, so that the project is completed within the due date with the budgeted resources. So, that is the challenge, how to sequence the various tasks. CPM and PERT is the kind of things which are there. CPM, critical path method, PERT, program evaluation and review technique. These are some of the learnings which we are going to have, how to manage the projects. Then come the job shop. There is a jumbled flow and not a uniform flow, and complex work with many exceptions. Each job is of a different nature. Whereas in a batch production system, this is disconnected line flow and moderately complex, not as complex as job shop, but obviously more complex than the mass production system or line processes. And line processes is the most simplest things to manage, connected lines and routine work. And continuous production, as I said, continuous flow and highly repetitive work. Continuous production also an example of mass production. This is also an example of mass production, but its output is continuous in nature. There are modern types of production system nomenclature is also there. We will see the features of these systems in our coming slides. Other types of production system, as I said, JIT production system, the idea is to develop a system which is flexible as well as productive, because our objective is quality, cost and delivery. Flexibility provides the delivery. If there is a change in requirements from the customer in terms of volume, in terms of mix, so we should be flexible enough, so that we are able to deliver the products as per the customer's requirement. At the same time, productive means the cost per unit should be low. I want to develop a system which is productive as well as flexible, so that I can achieve the objective of cost as well as delivery performance. Lean manufacturing system also talk about the same thing. By making the things lean, that means removing all known value added activities from the system, I can make the system lean and I can work with the help of that, so that my cost per unit is less. It is just like we are saying slim and healthy. So, if the system is slim and healthy, it will be more productive. So, same way lean manufacturing system. Then comes the flexible manufacturing system, FMS, which is most suitable for batch production system. Batch production system. I do not require flexibility in mass production system. I require too much flexibility in job shop production system, that no flexible system is able to provide that. So, the flexible manufacturing system is most suitable for batch production system. In this, you can, with the help of CNC machines and computerized programmed machines, you can change the settings of the machine and in a very fast manner, and you can produce a good variety of products with the minimum change over time. Then there is a agile manufacturing system, which is also called agility means ability to change very fast. If there is a change in the customer requirement, you should be able to change very fast, and this is especially useful for fashion items, technology items, where the requirement of the customer changes very fast and you should be able to change fast. Basically for innovative products. For innovative products, I should be able to, my system should be agile, so that I can change very fast. This is also called mass customization. This is also called mass customization. Then there is a quick response manufacturing, another term for such kind of a things, where you want to respond very fast. Then e-manufacturing is another term which is combined, which is more IT enabled manufacturing system. IT enabled manufacturing system, where many processes are managed, controlled with the help of IT, and now we are also called ERP also. ERP is used for that. Before the means when IT was implemented in fragmented manner, it is used to called e-manufacturing. Then obviously now supply chain management is a very popular and common term which is used. Different countries, Quad countries also, when we talk about they also work in improving the supply chain management between countries also, not only within the organization company. Now countries are also talking about collaborating to improve the efficiency or productivity of the supply chains across the country. Especially after COVID, there is a lot of work is going on, how to make supply chains more sustainable under this kind of a disruptions which came during COVID. Then obviously virtual manufacturing, in which it is more a global manufacturing, where different manufacturing activities take place at different geographies. Certain part is manufactured in India, certain part in Taiwan, certain part in some other country, and then it is getting assembled in some other country and sold to several other countries. So, those kind of manufacturing systems are called virtual manufacturing, and they are managed on a tabletop desktop computer. With the help of that, you are able to manage the such kind of virtual or global manufacturing sites. So, these are some of the new terminologies these days we are using it. Now, coming to the salient features of various types of production systems, starting with the mass production system. Starting with mass production system, first thing is we have to see that what type of layout I should have. What type of layout I should have? Since it is a mass production system, that means there is a very less variety, or maybe a typically you are producing one type of a product. So, what you are doing? You are arranging the processes according to the requirement of the product. If first step required on the product is lathe machine, second is milling machine, third is grinding machine, then I arrange my machines in the same manner the way product is required. So, in that case the layout is called product layout, where facilities are arranged according to the requirement of the product. Second important aspect which is required in mass production system is called line balancing. Suppose this machine A require 10 minutes to produce something, B require 15 minutes to produce something, and C require 5 minutes to produce something. How many units I am going to produce per hour? Obviously, the machine which is slowest in nature will decide the production rate. So, I will be able to produce only 4 units per hour. But if somehow I am able to transfer the 5 units of work from B to C, then A will have 10 minutes of work, B is having 10 minutes of work, and C is also having 10 minutes of work. By balancing the work for 3 workstation, I can now produce 6 units per hour. So, that is the concept of line balancing. That means, here I have shown a very small example of 3 workstations only. In engine assembly or in car assembly or other places, there may be more than 100 such kind of workstation, and if they are not balanced, you can see that there is a loss of efficiency. From the same setup, I am able to produce only 4 units, whereas by balancing the machines, I can produce 6 units per hour. So, that is the concept of line balancing we will study in facility design. Third important thing which is very critical in mass production system. Now, you see that all the processes are end to end connected, and that is why the quality is very important. If due to some reason this machine A is not able to produce the desired quality, the B and C will also come to a standstill. They will not be able to produce any product. Similarly, if the machine B is under breakdown, the whole line will not be able to produce anything. It will not be able to feed anything to the C, it will not be able to take anything from the A. So, whole line will come to a standstill. So, maintenance and quality management are very critical, highly critical in case of mass production system, because there is no alternates available, there is no routing flexibility available in the system. Now, what type of technology I should have for mass production system? As I said, the flexible manufacturing systems are most suitable for batch production system. Here I am preferring special purpose machines, usually called SPMs, because I do not require any flexibility. My machines, my jigs and fixtures should be such that they are meant only for one type of a product. By this, I am able to increase my productivity, and it is less expensive also. Similarly, moving the material from A to B, I do not require any flexible system. It can be simple gravity chute, by which material can go with the help of gravity from one machine to another, from one workstation to another, or it can be some kind of a conveyor belt or something can be there, by which material moves from A to B. No flexibility is required in this case, only transfer lines, a good roller chute or belt conveyor can be a suitable thing. What type of automation I should have? There is a concept of hard automation. I can go for automation which require the less worker requirement. I do not require any flexible automation, because I have to produce only one type of a product. So, no flexible automation is required. I can go for only hard automation. Worker requirements, because one type of product is produced and machine is capable of producing that, I need a low skilled worker for this particular type of a production system. Not highly skilled persons are required to operate these machines, which are special purpose machines, and there is no change in product also. So, not much skills are required. As I said earlier, the system has very less flexibility, but it is highly productive in nature. Now, coming to the second type of production system, which is batch production system. The batch production system has a process layout, because here I am not producing one type of product. I am producing different types of product X, Y, Z and like that. So many types of products I am producing. Usually 20 to 30 different types of products are produced in a batch production system. Same type of different type of gears or different type of sheet metal component or machining of the component or different types of molded components or like that you are producing. Or if you take the example of service system, maybe different type of pizzas you are manufacturing producing from the same setup. So, batch production system. Process layout, because here X may have a process of first A, then B, then C, whereas product Y may have first A, then C, then B, and product Z may have only A and C only. And like this, there are several combinations of process requirements are there for different types of jobs which I am manufacturing. So, that is why I cannot go for a product layout, because there are variety of products I am manufacturing in the given system. So, the layout is called process layout. All A types of machines I will keep at one workstation, another type of another department, another type of machines are kept another. So, product X will go from A, then it will go to B, and then it will go to C and then out, whereas Y will go from A, then it will go to C and then it will go to B and then it will go out like this. Products Z, it will go from A, then it go to C and then it is out like this. So, you will find there is a crisscross movement also. I have shown only 3 workstation, but if there are 20, 30 workstation, you will find that there is a backtracking, crisscross flows are there in batch production systems. So, that is why layout is very, very important. The most important issue in batch production system is layout. So, that you design the layout in such a manner that the material handling or material movement is minimum, whereas no such issue is there in the batch in the mass production system. In mass production system, my flow of the material is highly uniform and unidirectional in nature, whereas in case of batch production system, the flow of material is in multiple directions, and there may be another product Z dash which may have a flow of C, B and A also. So, in that case it will first go to here, then here to here and then here and then again going out. So, there may be several kinds of flow are possible, and again repeating, we have considered only 3 types of machines or equipment here. The total requirement may be 20 different types of operations can be there. So, layout planning is very, very important in batch production system. It is not critical in case of mass production systems. Now, from the same setup I am producing, let us say 3 different types of products X, Y and Z. Obviously, first I have to produce X for certain period, then I produced Y for certain period, then I have to produce Z for certain period. So, I have to produce in batches. Let us say for example sake, for a per year annual demand of X is 1 lakh units per year. The demand of Y is let us say 2 lakh units per year. Demand of Z is let us say 3 lakh units per year. Okay. Now, one possibility is I produce 1 lakh units in January and February. First 2 months I consume to produce X, then next 4 months I am producing this and next 6 months I am producing this, total 12 months in a year, and again start repeating X, Y and Z in the same cycle. Second option with me is first I will produce only 1 unit of this, then 2 units of this, then 3 units of this, again producing 1 unit of this, 2 units of this, 3 units of this, and by this I keep on doing this manner. So, if I say this is my option A, this is my option B, question arises which one I should prefer. What is there? In option A, if you look at option A, you will find the changeovers are very less, only 3 changeovers in a year, but cost of carrying inventory is very high. Something you are producing in January and consuming till December. So, the cost of inventory is very high, whereas the changeover cost is very less. Whereas, in case of B, you will find the cost of carrying inventory is very less, because you are producing in very small quantities, but you are doing almost 3 lakh changeovers in a year. So, in that context we will find A and B both are not very good. I need some policy in between. I need some policy in between. I need some policy neither A nor B, something in between, by which I can reduce the total cost of inventory carrying as well as the changeover cost, and that quantity is called economic batch quantity. That quantity is called economic batch size, the batch size for which the total cost of carrying inventory and the cost of changeover is minimum. So, I hope you understood the concept of batch production, that is why the process the layout is very important and why the decision of economic batch quantity is very important. Now, look at the mass production system. Since you are producing same type of products for a longer period, there is no concept of economic batch quantity here. Now, third important aspect, as I said, what type of technology I should have, what type of equipment I should have. If I am having these equipment as flexible equipment, then they are good enough to produce X type of product, Y type of product and Z type of product. Any product can go to any of the machines. So, that is the kind of flexibility which is required, or maybe I can have one flexible center which can produce all types of products and which can do many operations also, by which I can reduce the material handling efforts and other things. That is called flexible centers, flexible manufacturing centers also. Now, question arises, what type of material handling equipment I should have. Now, you have seen that material from A can go to B also, it can go to C also, and so on. There are several types of possibilities are there. So, transfer lines are not going to work in this case. I need automated guided vehicles, which are popularly called AGVs, and these days we are using the boats also for this purpose. Robots and other things also we are using for transfer of the material from one workstation to another in a flexible manner. So, we need a flexible material handling system for the purpose of batch manufacturing, batch production systems. What type of automation? Flexible automation is required. I need automation as well as flexibility. You should understand that automation and flexibility are two independent dimensions. It is possible that you can have automation, no flexibility, low automation, low flexibility. You can have high automation, low flexibility. You can have low automation and high flexibility. You can have high automation and high flexibility also. So, different types of production system can be there, which can be highly automated as well as highly flexible also. All your general purpose machines falls here. We will use general purpose machines in case of batch, in case of job shop production system. Highly automated, low flexibility, your special purpose equipment machines will come here, and your flexible manufacturing system is coming here, which is highly automated and highly flexible. Low automation, low flexibility is not a very good productive system. So, in that sense we can see that we need flexible automation for batch production system. Coming to productivity, the batch production system has low productivity as compared to mass production system, and because you have to do the changeovers and other things, which there is a loss of time. And because of this there is another important observation I want to make here. As I said before, 1980s most of the systems were mass production system because the variety was very less. As the variety start increases, the batch production system becomes more and more popular and useful, and this is where the need for supply chain management and other JIT manufacturing system and lean manufacturing system started. You will find in our curriculum in India, we are teaching or studying supply chain management only after 2000. 2005 or 2004, supply chain management subject came into the curriculum only at that stage when the variety started increasing. So, in that context we can see that there is a change which has taken place after liberalization and after globalization of the economy. Now, coming to the third type of a production system, that is job shop production system. And here also we are using the process layout as we have used for the batch production system, because there is no standardized product, only we have to keep one type of processes at one place. Here there is no question of economic batch quantity. Who will decide the batch quantity in job shop production system? Customer will decide the batch quantity. If I have to get the 2 shirts of similar type stitched, so my batch size is 2. If I want only 1 shirt to be stitched, the batch size is 1. So, here the customer decides the batch size. We need not to calculate the economic batch quantity. But important thing is scheduling, sequencing and routing. Different jobs require different type of process requirement. So, how to route these jobs into the shop, just like service center. Maybe you are doing servicing of 200 different cars in a day, and each car has a different process requirement, because they are coming for different type of activities. So, how to route those cars in the service center, and with the twin objective: one, the waiting time of the car is job is minimum, waiting time of job is minimum, and the second objective here is the idealness. The machine should not be ideal, so machine should be minimum. Machine or resource, not only machine, even manpower or any resource which is required in the process should be minimum. So, that is the requirement in doing the scheduling, sequencing, routing. In what sequence I should schedule my jobs, so that the total time taken to process all the jobs is minimum. In what sequence they should be arranged. So, that is kind of we are going to study one chapter as scheduling, sequencing, routing also. So, when we are studying that, you should be able to connect that this subject is not required for mass production system, this subject is not relevant for batch production system, this subject is relevant only for job shop production systems. Because the variety is very large, we need general purpose machines. No special purpose machines are going to be suitable, no flexible manufacturing system is going to be suitable for this. We need general purpose machine which are having very less flexibility and very less automation. Human skills are going to play a very important role. We can add here another dimension: highly skilled worker is required. Highly skilled worker is required in job shop. Like just like in a tool room, in a service center, as a tailor, we need highly skilled worker, because the quality of the job is going to be not governed by the machines, but by the skill of the worker, and obviously this system has a low productivity. I hope you have understood the difference between a mass production system, batch production system and job shop production system, and you have also seen that there are certain type of management aspects which are different in these types of production systems. Let us see the service systems also. What are the typical features of a service system, service organizations? One and foremost difference between service organization and manufacturing organization is customer participation. When you are using the transport, airline, you are part of the conversion process. When I say customer participation, you are part and parcel of the conversion process. You are using the ATM, you are part of the conversion process. Similarly, in education, in hospital, you are part of the transformation process also as a customer, whereas manufacturing of the cars, manufacturing of pens, you are not part of the conversion process. So, that is one important aspect which is different in service organization as compared to manufacturing organization. In manufacturing organization, customer is not part of the conversion process, whereas in service organization, customer is part of the conversion process. Second important difference in manufacturing and service sector is you can produce the product and store it, and it can be used at a later stage. Whereas in case of services, airlines, seats are there. If a customer is not using it, it is going to be waste. So, you cannot store the services, you cannot inventory the services. So, that is important. It has to be consumed when it is getting produced. So, service capacity is time perishable. If you are not able to use it, it is going to be perished. The location of the services is governed by the customer. airlines will have the routes where the customer is. Restaurant, you will open the restaurant where the customers are. Retail chains, you are opening a retail outlet where the customer is. Hospitals and so on. So, the customers are local in nature, whereas in case of manufacturing the customer can be national, customer can be global in nature. And generally services are more labor intensive and the nature of the service is intangible, whereas products are tangible in nature, you can feel it. Services you cannot feel it physically. So, these are some of the differences which make the design of services different. When we do the second chapter, that is design of products, services and processes, there we will study more in detail how to design the services and how to deliver the services. And I would like to bring to your notice, earlier the subject of production and operations management used to be called production management only. After this service sector started growing, the subject is named as production and operations management. But now I am observing after 2015 or so, the subject is being named as operations management only. And the books are also on the subject, earlier used to be called books are coming under the title production management, they started coming as production and operations management. Now, the books are also started coming as operations management. Operations management includes both manufacturing of products as well as services. You will find the change which is happening. Now, service sector has grown to almost 54%, whereas if you look at 1950s data, this was even less than 20%. In 1950s, service sector was less than 20%. Now, it is in our GDP, its share is around 54%, and in globally the share of service sector is about 63.5%. So, you will find that service sector is growing much faster as compared to agriculture sector and the industry or the manufacturing sector. So, that is one of the reason that the subject is also evolving more towards service sectors, but you will find the principles and theories are almost same whether it is a manufacturing sector or it is a service sector. And it is also very difficult and it is becoming now to distinguish whether a given sector is manufacturing sector or a service sector. Let me share one example with you. There is a company manufacturing carpets, and one fine morning the owner of the company called his senior executives and asked them in what business we are in. Senior executive thought that why he is joking, he knows that we are in a business of manufacturing carpets. Obviously, they said that okay, we are in the business of manufacturing carpet. He said that okay, till today we are in the business of manufacturing carpet, tomorrow onwards we will be in the business of providing floor comfort to the users. That means, rather than focusing on the manufacturing, we will more focus on the service to the customer. So, once you decided that you will be more focused towards service, so what happens to this company of carpet manufacturer? Rather than focusing on manufacturing, they started focusing on service. So, in the process, the salesperson were going to the user, showing the various designs etc., and rather than purchasing the carpet, you can hire it for 1 year. So, the team will come, will place the carpet in your house, and for 1 year you can use it, and these guys will also maintain the carpet for 1 year. If there is some patch damage, so they will come and dry clean it. If it is beyond dry clean, they will replace that, they will cut that portion and will get it replaced by the same flower or same color piece from their store. So, that way you are improving the customer experience of the product, and with that what will happen now? The total value addition which were coming earlier 95% from manufacturing and 5% through marketing and sales, now you will find 60% of their value addition is coming through the services and 40% of the value addition is coming from the manufacturing. So, this is how a typical manufacturing organization became a service organization. So, that is why we can see the manufacturing sector and a service sector as a continuum, rather than looking at a particular organization as a manufacturing or a service only. You will see the car manufacturing companies also, along with manufacturing the car, they are also doing the insurance business also, they are doing the service center also, after sales service and service centers also. So, now for a typical car manufacturing company, maybe 50% of their value addition is coming from the manufacturing and another 50% is coming through these allied services which are non-manufacturing activities. So, like these sectors are moving from one direction to another, and that is a good development. They are integrating the service aspects in their business portfolio for better customer experience. Now, friends, let us look at the operations management, production management, various decisions and various concerns with the help of a life cycle approach. We will divide the total life cycle of the product into 8 stages. You all know life cycle means product is at the initial stage, this is time versus growth of the product, increase in demand. Initially the demand is less, then it grows, then it becomes the mature and stable, and after some time the decline, and then there is a decay of this. And to maintain, though the product is following this particular graph, to maintain the growth of your organization, maybe at some time you are launching a new product, by the time first product is phasing out, you are launching another product, it will take. So, individual product may have a certain lifetime, but your organization may survive for few decades and centuries. So, that is the concept here. So, we will see for one particular product how what are the various stages of its life and what are the important decisions and considerations at each stage of the product life cycle. Starting with the stage 1, that is called birth of the system, At this stage, you have to decide, it is just like after doing graduation, you want to set up your own, you want to be an entrepreneur. That is the stage where we can call it is a birth of the system, where you are trying to see, okay, why I am wanted to be in business, why I want to be an entrepreneur, what is going to be my corporate goals at that stage, whether I am going to be in business to earn a hell of a money, or I want to be in a business to serve the some sector of the society which are not able to get the right type of products, or I want to produce a premium product so that everyone can connect that, oh, here is a product which is very good. So, that kind of a thing you have to decide what is going to be my corporate goals, and then you have to decide whether I want to be in a manufacturing or I want to be providing the services to the users. For I want to be a manufacturing organization or a service organization, or how much manufacturing, how much service I should keep it in my portfolio. So, that is the first stage. What are the important considerations? Each stage is having two aspects. One is the type, nature of decisions, and how these decisions should be taken. What should be considered in taking those decisions. So, I have to see that what are the long term trends of this. So, demand forecasting will play, or your vision will play a very important here, or the forecast or prediction will play a very important role here. You should be a visionary leader, you can see something which others are not able to see. So, you will see what is the trends of growth of some new products, like today we can talk about electric vehicles. So, you have to see that if you want to come into electric vehicle business, what is the growth trends of this particular activity, and then whether you have the necessary technologies for it or not, or what are the new technologies which are coming into the market. Maybe with respect to many startups are coming which are integrating the several activities. So, you have to look at that. Several service sectors, startups, technology companies are coming with platforms. So, maybe it is a car integrators or a hotel integrators or like that, several such kind of companies are coming on the strength of technologies, new technology. Then also you have to see what is the preference of the consumer, in what direction they are going to work, what are the demographics of the country or the population is going. It is going to be nuclear families, or their taste for tourism and other things. Based on that you have to decide. Then what is the industrial climate, whether the countries or states are promoting the industries or they are more focusing on service sector, or what are the government policies in this way are working, and whether the climate is conducive, labor position, labor shortage, labor unions and such kind of things, whether you have the necessary raw materials available or not. So, all these factors you have to consider at this stage, and then to decide the corporate goal, you have to see what is your basic desire, why you want to be in business, what is your commitment, how much resources, how much money, what type of expertise you are having, and then what is your experience, your partner's experience or family members' experience in that. And then you have to see how much resources you are having in terms of manpower, in terms of money, in terms of land and other such kind of resources. So, your competitive priorities can be with respect to you have to see that corporate you scan environmental scanning, core competencies, core processes and global strategies, you can look at that, and then you can decide your competitive priorities on cost, quality, delivery performance and flexibility. So, further elaborating on that, how to consider the decisions at stage 1, I have to see what is my corporate strategy, what type of products, markets I am going to enter into, and what is going to be my order winning dimension, whether I am competing on cost or I am competing on quality or I am competing on delivery performance. Just I said that 19 minutes of delivery, within 20-minute delivery, that is my order winning dimension. Or what is and another important philosophy and policies of my organization. Then for to decide that, I will scan the environment, core competencies and core processes and global strategies I will going to follow. From this I will design my operational strategy, how much flexibility I should have, what type of technology and processes I can have, where I am going to locate my factory, quality aspects and human resource related aspects. Based on this, I will decide my products and markets, pricing, promotion and customer service. Now, coming to the life cycle stage 2, where we are talking about the design of products and services and then selecting the appropriate technology for that. Here, when we say design of the product, I am not only interested in features, also the form and shape. When the form and shape, we say that something which help in selling the product and appearance of the product, and when it talk about the features, that means something which fulfill the requirements of the customer. And then based on the product design, materials etc., I have to select the and volume and variety. Based on that, I will select the appropriate technology, appropriate process, whether I need automation, whether I need flexibility, what should be the size of my factory and what is going to be my sequence of operation and like that. So, that is the stage 2 decisions. What are the important considerations here? I will look at the customer needs, I will look at the behavior of material, what type of material, whether I should go for metals, non-metals, plastics or something else, or what are the available processes, whether I am joining the materials with the help of welding or some other process, or I am doing the molding or a single piece like that. And then I have to see the economics also. What is going to be the break even point here? What is the break even point I am going to have here? And during process selection, I have to see what are the technologies which are available, what is the economics of those technologies and what are the required specifications of that. Now, coming to the life cycle stage 3, here I am talking about the location, where should I locate my factory and the layout, physical arrangements of the this, and how to determine demand of the product, how to forecast the demand of the product. So, these are the important aspects at life cycle stage 3. And important considerations, I will go for the surveys and feasibility studies of different locations. I will see what is the economics of mass production system, batch production system, job shop or product. I will go for layout planning, quality assurance, demand forecasting etc. at this stage. Now, coming to the life cycle stage 4, now my technology part is done, I have to do the manpower planning. So, manning of the system, how many persons are required, what each person is going to perform, what job each person is going to perform, how much, what type of skills are required and so on. So, based on that, I will decide the manning of the or manpower planning of this system, and I will perform the method study, how many units are going to be produced, what method they are going to follow and so on, and how they are going to be paid, wage incentives, salaries, wages, incentive scheme etc. I am going to design at this stage. The consideration here is work measurement, setting of production standards, wage incentives, capacity determination and planning of the resource acquisition. Now, coming to the stage 5, Now, your factory is in place, manpower is also in place. Now, when you are start, some initial problem may come. Then you have to see that now you are coming into the productive phase, how in a minimum time you should be able to resolve those problems. Initial problems can be related to installation, it can be related to coordination, it can be training of the personnel, it can be the learning of the system also. So, these are the problems which are going to come, and we want to overcome these problems as fast as possible. Coming to the stage 6, now the system is at a maturity stage, full working. So, we have reached to this stage when it is going to be productive, stable, this. So, this is where the maximum profits will come. So, the next is the life cycle stage 6. At this stage, we reach to the point here where we can say that now system is in full capacity and we should get maximum advantages from this. So, all types of controls will come at this stage, how to run the system, so that I get maximum output from the system. What are the decisions which I have to take? Here I have to set the targets, and then I have to do the scheduling, sequencing of the job, more operational level decision. I have to do several types of controls in the form of inventory control, quality control, production control, cost control and maintenance of the system. Now, coming to the stage 7, that is revision of the system. Now, we are at a stage when the demand of the product is declining, this stage of the system 7. At this stage, I have to see that how to revise the system in the light of changing external condition. There may be change in the demand, there may be change of other aspects. So, how to revise the system? The important consideration here are new technologies, threats and opportunities, revision of market demand, newer products, technological innovation and newer methods of manufacturing. Life cycle stage 8, termination of the system. Now, system is no more useful because of the change in technology or change in customer demand. So, how the system should be write off, die. Idea is you should get the maximum economic advantage and minimum harm to the environment. And important consideration here are manner of phase out, sell out merger and start a new product. So, in this way we can see that there are several decisions we have to take which are relevant for different life cycle stages, and different decisions will so various technologies etcetera which we are going to study, they will be relevant for different stages of the life cycle. So, with this we come to the end of this introductory lecture which we have covered in 2 parts, 2 classes. Thank you very much.